Okay, so this second set of videos on solutions deals with determining the molarity of the solution, either by directly making a solution or adding two solutions together or diluting a solution. So let's just start with the simple idea of what is molarity. So molarity is a ratio, like all descriptions of solution. In this case, it's a ratio of the moles of the solute per liter of solution. So when you make a solution, you would pour your solute into your volumetric flask usually, and what you would do is you would pour that solute in there, it would go to the bottom, and then once you had that in there, okay, you would add a little bit of liquid and you would slowly fill it up until, and make sure it all dissolves, and then fill it up to the mark here. Alright? And the idea is it's the liters of solution. So the volume is not the volume of water you're adding, but the total volume of the solution, which includes whatever space the solute actually takes up. So let's, for example, let's say we had 80.0 grams of NaOH, and we're putting that in to make, watch the wording, a solution with a total volume of 250 milliliters. All right, so what will be the molarity of that solution? Well, we need to know the moles of solute, and we need to put that over the liters of solution, and that will give me the molarity, which is just a way of saying moles per liter. So the formula mass of NaOH is 40.0 grams. At this point, hopefully you recognize that if I have 80 grams of NaOH, if the formula mass is 40, I've got basically 2 moles. So I have 2 moles of my solute, and my final volume is 250 milliliters. So we're going to convert that into liters. So we'll put that over 0.250. I converted the milliliters to liters, and that will give me 8 point. If I'm doing sig figs from the beginning, which I'm not, I kind of skipped there. This would be 2.00, 8.00 molar solution, or 8 moles. That's equal to 8.00 moles for every liter of solution that I have. Now, one of the things you can do if you had a different substance, they can ask you what the concentration of the individual ions are. So imagine I had an 8.00 molar solution of, let's say, barium, chloride. Okay? Well, that would mean that for every liter of solution, there's 8 moles of barium chloride in there. But what you want to recognize, when the barium chloride got into the water, the ions disassociate. And whenever this disassociates, for every 1 barium 2+, I get 2 of these chloride ions. So the concentration, I'm going to use brackets here, the concentration of the barium ions would be the same as the concentration of barium chloride, because it's a 1-to-1 relationship. So that would be 8.00 molar with respect to the barium ion concentration. But the chloride ion concentration would be different. And the reason why is for every 1 barium, there's 2 chlorides. So the concentration of chloride ions would be 6.00 molar. Now you should be able to manipulate the equation. So let's say if you're given the molarity and the volume, you should be able to go backwards to get the number of moles. So if you look at the formula as being molarity equals N, which is moles, over the volume in liters like that, you can cross multiply, and so the molarity times the volume will be equal to the number of moles, as long as the volume is in liters. So if, let's say, you had an 8.00 molar solution, like you did before, but you only had 100 milliliters of it, you could figure out how much solute you have, because if you took the 8.00 molar, that's really 8.00 moles per liter. If you had 100 milliliters, right, you could multiply your molarity times your volume, which is 100 milliliters, and the liters will cancel out, and that tells you get 8 times 100, or you got 800 millimoles. And 800 millimoles is just 0.8 moles. So make sure you can manipulate the equation. Another type of problem involves the addition of solutions. So imagine you had 100 milliliters of an 8.00 molar solution, and you want to add to that another 10 milliliters, okay, of, let's say, a 2.00 molar solution of the same substance, and you're asked, okay, what is the final molarity of that solution? Well, you still want to know the moles per liter. Now you assume that the volumes, this is key, the volumes are going to be additive. If they're not additive, then you're going to have to deal with things like density, and I haven't really seen a lot of that showing up on the AP exam. So what you can really do here is figure out how many moles, and I'm going to do this in millimoles because it's easier, and you'll see why in a second. So I'm just going to take these numbers and multiply them. I'm going to take the 100 times the 8, okay, which gives me 800 millimoles. So I've had 800 millimoles in the first solution, and I'm adding that to 2 times 10, and I'm adding, in this solution, I have 20 millimoles. So when I add the two solutions, basically, I have 820 millimoles, right, because all I did was I did the V times the M, and the V times the M, and because I'm keeping it in milliliters, I get my answer in millimoles instead of moles. If it was in liters, I get moles. So now I have 820 millimoles, and all I have to do is put that over the total volume. And my total volume in this particular case is 110 milliliters. Now the cool thing about this is the millis actually cancel each other out. Now I'm going to pause and get my calculator. So when you divide this through, basically you get mole per liter. So you get 7.45 moles per liter. And that's your new molarity. You already know how many millimoles are in there, which is the same as 0.82 moles, and you have your volume. The last type of question you're going to get is a dilution. Now I'm just going to give you straight up the formula here. Molarity case 1 times volume case 1 equals molarity 2 times volume 2. The difference in the dilution is basically these guys are both equal to n, and n is the number of moles. The concept in this thing is that when you dilute something, you're not changing the moles of solute, you're just changing the volume. So, and usually you start at a lower volume and you go to a larger volume, because when you dilute, you're basically adding water. So let's say you had a 2.0 molar solution of something, and its original volume was 10 milliliters, right? And then what you do is you dilute that up to a new volume of 50 milliliters. Now when you solve for x here, you're basically going to get 2 times 10 divided by 50, which is going to give you a 0.4 molar solution. And that should really make sense, because if you think about this, it's going to be 1/5 the original concentration. This is an indirect mathematical relationship. It looks like the formula for pressure and volume. You've seen a few of these. This is an inversely proportional relationship. So when one thing goes up, the other thing goes down. So they multiply out to the same number, which the same number is the number of moles. So whenever doing a dilution, include the molarity and the volume that you have that correspond, and set them equal to the new volume to figure out the new molarity. Or the other type of question you might see in this case is they give you the new molarity and ask you what the new volume will have to be. Make sure we're clear though, if they do it that way, so if they give you like 2.0 molar times 10 milliliter, and I want my new volume to be 0.4 molar, right? Well, when you solve for this, obviously you're going to get 50 milliliters. That is not what you're going to add, nor are you going to add 40 milliliters necessarily, although you probably will be. However, what you're going to do is you're going to add enough water to make a final volume of 50 milliliters, and that's the way you would present that.